why grass is green, or if that dress is really black and gold, or white and blue. These questions can be answered when we shine a light on colored light and how we perceive it. First, we will look at why things have color. Then we'll learn a little bit about the structure of the eye and the receptors that respond to light. Last, we will discover what happens when colored light hits different colored light. But first, what is light? The white light, or natural light, we're used to seeing, such as light bulbs and the sun, is really just all of the colors of the light spectrum mixed together. To understand colored light, we must understand what gives an object color. According to colortherapyhealing.com, an object's color comes from its chemical makeup. All things are made of atoms and electrons. Some objects have more free electrons that are able to pass from atom to atom. When light hits these electrons, more light is reflected because the electrons absorb the light, but instead of passing the light to other atoms, it vibrates and reflects the light out, sending the energy out. The reflected light is the color we see. The rest of the lights that you don't see are absorbed into the object. Light reflected hits the light-sensitive retina in the back of your eye. Stephanie Pappas, in her article, How Do We See Color?, describes cells in the retina called cones. These tiny cells respond to light. Humans have about 6 million of them in their eye. Not all cones are the same. There are three types in humans. 64% respond most to red light, 32% respond most to green light, and only 2% respond most to blue light. When these cones are stimulated, they all react to different degrees. Then they come together to create a signal that is sent to the brain through the optic nerve. Once in the brain, the signal is processed and the information is processed to come back and figure out the color. Now that we've kind of figured out how we perceive light, what happens when one colored light hits another colored light? For example, say you have filtered light that's filtered so only blue light is shining through. When you shine this on a red object, no light comes through. It appears dark because the red object is absorbing all light except for the red light, but only blue light is being shown on it. So it looks completely different from what it does with a different light. Other times when you may use a camera flash or compared from a classroom setting to outdoors, things may look different because of the natural light or the light shining into it. Michael Calhoun talks about this in his article on education.com. He explains about filtered light and an experiment you might like to try about seeing how different lights affect other colors. So now we know some interesting qualities of light. An object's chemical makeup determines what color will be reflected. Once reflected, the cone cells are stimulated, sending signals to the brain. And if a different light is shown on an object, it might appear completely different. I hope you're no longer in the dark about light.